Welcome back to the deep dive. If you are deep into your ATPL theory prep, you definitely know things get, well, a lot more complex when you push towards transonic speeds.
Oh, absolutely. High-speed flight, jet operations. You're leaving the simple world of the basic airspeed indicator way behind.
Yeah, you need real precision. Measuring your speed relative to the speed of sound itself, it's a whole different ballgame.
That's right. And for anyone tackling those ATPL subjects, the Machmeter isn't just another dial on the panel. It's really fundamental to understanding the limits, the aerodynamics of high-performance flight.
So our mission today is a proper deep dive into the Machmeter. We're going to try and distill the core physics, look at the clever mechanics of its design.
And critically, those really complex, sometimes counterintuitive relationships between calibrated airspeed, true airspeed, and Mach number, especially when the aircraft's moving dynamically, climbing, or descending.
Exactly. We've pulled together technical source material covering, well, pretty much everything from the physics of sound speed to how the instrument's built, and crucially, the errors you need to account for.
And we're really focusing hard on the knowledge you need to nail those tricky exam questions. You know, the ones that always seem designed to catch you out?
Yeah, we need to get beyond just memorizing definitions.
Yeah.
We need to understand the why behind the rules, the operational procedures.
Precisely. And you'll hear us repeat some fundamental rules several times, especially when we talk about climb and descent profiles. Things like why climbing at a constant CAS makes your Mach number shoot up so fast.
Right, because those aren't just theory points, they're everyday operational realities that examiners absolutely love to test. So let's get into it.
Okay, let's start right at the beginning. The fundamental why. Why bother with a whole separate instrument just for Mach number? You've already got an ASI, right?
Good question. It seems redundant at first glance.
Well, it all comes down to the air itself, the aerodynamics, when you start going really fast. As the aircraft speeds up, the air flowing over certain parts, think the top curve of the wing, the canopy.
Places where the air has to accelerate.
Exactly. That local airflow has to travel faster than the aircraft itself. So maybe the plane's doing Mach 0.7, but the air rushing over the wing might be getting dangerously close to Mach 1.0 or even exceeding it locally.
And when that local flow hits Mach 1, that's where the trouble starts. Shockwaves.
Precisely. You get these localized shockwaves forming, and they really mess things up. The big problems, the critical ones you need to know are a huge jump in drag. They call it wave drag.
Okay.
A significant drop in how well the wings generate lift, potentially severe buffeting, shaking the whole airframe.
Right.
And critically, a loss of control effectiveness, especially the elevator. It might just not respond as you expect it to.
And that leads us to the single most dangerous potential outcome, and this is a term you absolutely must know for the exams, Mach tuck.
Mach tuck, yeah. It describes this sudden, uncommanded pitch downwards. The nose just wants to drop.
And what causes that specifically?
It's the shock waves forming on the wing. As they establish and strengthen, they cause the wing's center of pressure, the average point where lift acts to shift backwards towards the tail.
Okay, the lift moves aft.
Right. And if it moves far enough back, it creates this powerful nose-down pitching moment. It can be so strong that the pilot might struggle to counteract it with the elevator, leading to a steep, high-speed dive. Really dangerous stuff.
Sounds absolutely terrifying. So, obviously, we need a way to prevent getting anywhere near that state.
And that's where the limit comes in. Every high-speed aircraft is certified with a specific maximum operating Mach number, or MMO.
MMO. Got it.
This isn't some theoretical number. It's determined through really rigorous flight testing for that specific aircraft type. It ensures there's a safety margin before these really bad shockwave effects take hold.
So the Machmeter is essentially the pilot's gauge showing how close they are to that absolute MMO limit.
Exactly. It's just as critical a limitation as VMO, the maximum indicated airspeed. You simply do not exceed MMO, period.
Okay, so if Mach number is fundamentally TAS divided by the local speed of sound, LSS, we really need to pin down what determines LSS.
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best